how they feed, or how they care for their young. 4. Data collected. The researcher might note specific events, like how often chimps groom each other or how they react to new individuals entering their territory. 5. Results. After compiling their observations, the researcher might conclude that grooming is a crucial behavior for maintaining social relationships among the chimps. They might also identify specific behaviors that indicate stress or aggression. Conclusion. Naturalistic observation is a valuable research method, especially in ethology, that allows researchers to study behavior in real-life settings without interference. It provides insights into genuine, spontaneous behavior and helps researchers understand how animals, including humans, interact with their environment. Understanding naturalistic observation will enhance your ability to evaluate research methodologies, which is important as you prepare for your CPC exam. Participant observation. Sure, let's explore participant observation, a research method used in various fields like sociology, psychology, and anthropology. This method allows researchers to gain in-depth insights into a group or community by actively engaging with them. We'll break this topic down into key concepts, important details, and examples to make it easy to understand. What is participant observation? Participant observation is a qualitative research method where the researcher becomes a part of the group or community they are studying. By participating in the daily activities of the group, the researcher aims to gather data and understand social interactions, behaviors, and cultural practices from an insider's perspective. Key concepts. 1. Active participation. Unlike other observational methods where researchers remain outside observers, in participant observation, researchers engage directly with the group. This means they often take part in activities, conversations, and daily routines of the people they're studying. Example, a researcher studying a local community club might join meetings, participate in events, and socialize with the members to understand their dynamics better. 2. Understanding context. By immersing themselves in the environment, researchers can comprehend the context surrounding behaviors and interactions. This helps them capture subtleties that might be missed through more detached observation methods. Example, if a researcher is studying the eating habits of a specific cultural group, participating in meals allows them to understand not only the types of food eaten, but also the significance of those foods in that culture. 3. Building trust. Being an active participant helps researchers build rapport and trust with members of the group. This often leads to more open communication and authentic behaviors, making the data collected richer and more reliable. Example, a researcher studying youth behavior in a high school may gain trust by participating in school activities, allowing students to feel more comfortable sharing their thoughts and opinions. Important details. 1. Types of participant observation. Overt participant observation. In this approach, the participants are aware that they are being studied. The researcher is open about their role as a researcher. Covert participant observation. In this case, the participants are unaware that they are being studied. The researcher may conceal their identity as a researcher to capture more genuine behaviors, but this raises ethical concerns related to consent and privacy. 2. Data collection. Researchers collect data through direct observation, field notes, interviews, and recordings. The data is often qualitative, focusing on detailed descriptions of behaviors, interactions, and social contexts. Example, a researcher observing a religious community might take extensive notes about rituals, conversations, and member interactions to later analyze and interpret their findings. 3. Advantages of participant observation. In-depth understanding. It allows for a deeper understanding of social dynamics, motivations, and context, which can reveal insights that surveys or interviews might miss. Rich, qualitative data. The method provides detailed, descriptive information that helps researchers understand the complexities of human behavior. 4. Limitations of participant observation. Subjectivity. The researcher's presence may influence the behavior of participants, and personal biases can affect interpretation and analysis. Time-consuming. Engaging with a group over extended periods can be time-consuming and requires significant commitment. Ethical concerns. Especially in covert studies, ethical issues related to consent and deception may arise. Researchers must ensure they're not violating participants' rights. Example of participant observation. Let's consider a researcher studying the behavior of a basketball team. 1. Research goal. The researcher wants to understand team dynamics and cooperation during practices and games. 2. Setting. The researcher decides to join the basketball team as a practice player throughout the season. 3. Data collection. While participating in drills and games, the researcher closely observes the players' interactions, communication styles, and how they respond to coaching. The researcher takes field notes after practices, where they document observations about teamwork, competition, and individual players' attitudes. 4. Results. After gathering data for an entire season, the researcher may find that certain players tend to take on leadership roles during crucial moments, while others contribute more behind the scenes. This information provides insights into the social dynamics of the team and aids in understanding how these dynamics influence performance. Conclusion. Participant observation is a valuable research method that allows researchers to immerse themselves in the lives of the people they study. By actively participating in a group's activities, researchers gain rich insights into social interactions and cultural practices. This method helps reveal the complexities of human behavior, making it essential for understanding groups and communities. Having this knowledge will be useful as you prepare for your CPC exam and develop analytical skills for evaluating research methodologies. Correlational research. Sure, let's explore correlational research, a common method used in psychology and other fields to understand how two or more variables relate to each other. We'll break down the key concepts, important details, and provide examples to clarify everything. What is correlational research? Correlational research is a type of study that investigates the relationship between two or more variables to determine how they are associated with one another. This research helps scientists identify patterns, but does not imply that one variable causes changes in another. Key concepts. 1. Variables. In correlational research, a variable is something that can change or vary. Examples include height, test scores, temperature, age, or behavior. Researchers look at how different variables interact or relate to one another. Example, a study might examine the relationship between study time and test scores. 2. Correlation coefficient. The correlation coefficient is a statistical measure that shows the strength and direction of the relationship between two variables. It ranges from -1 to +1. Positive correlation. As one variable increases, the other variable also increases. Negative correlation. As one variable increases, the other variable decreases. No correlation. There is no predictable relationship between the two variables. Example, if the correlation coefficient between study time and test scores is +0.8, this indicates a strong positive correlation. More study time is associated with higher test scores. 3. Scatter plots. Scatter plots visually represent the relationship between two variables. Each point on the graph represents a pair of values for the two variables being studied. The pattern of the points can show whether there's a positive, negative, or no correlation. Example, in a scatter plot showing study time on the x-axis and test scores on the y-axis, a group of points that slope upward from left to right would indicate a positive correlation. Important details. 1. Types of correlational research. Positive correlation, when both variables increase together. Negative correlation, when one variable increases while the other decreases. Zero correlation, no apparent relationship exists between the two variables. 2. Limitations of correlational research. Causation versus correlation. One important limitation is that correlation does not imply causation. Just because two variables are correlated does not mean that one causes the other to change. Example, if there's a correlation between ice cream sales and drowning incidents, it doesn't mean that buying ice cream causes drowning. Instead, both may be influenced by a third variable, like warm weather. Third variable problem. Sometimes, another variable can affect both variables being studied. This can lead to misleading conclusions if not accounted for. Example, a correlation exists between the amount of time spent playing video games and grades in school. Without considering other factors, one might incorrectly conclude that video games cause poor grades. 3. Usefulness. Correlational research can help identify relationships and generate hypotheses for further study. It is often used in social sciences, education, health, and psychology to gain insights into patterns and trends. Example of correlational research. Let's say researchers want to study the relationship between exercise and mental health. 1. Research goal: to determine if there is a relationship between the amount of exercise people engage in and their reported levels of happiness. 2. Variables. Variable 1, amount of exercise. Variable 2, happiness levels. 3. Data collection. Researchers survey a large group of people to gather data on their weekly exercise habits and their happiness scores. 4. Results. If the researchers find a correlation coefficient of plus 0.7, this indicates a strong positive relationship. People who exercise more tend to report higher levels of happiness. 5. Interpretation. Although there is a correlation, the researchers must be careful in interpreting the results. They cannot conclude that exercising causes higher happiness without further research to rule out other influencing factors. Conclusion. Correlational research is a valuable method for exploring the relationships between variables to identify potential patterns and make predictions. However, it's crucial to remember that correlations do not indicate causation, and other factors may influence the observed relationships. Understanding this concept will help you critically evaluate research findings, which is essential as you prepare for your CPC exam. No direct manipulation of the 4. Sure, let's discuss the concept of no direct manipulation of the independent variable in research, particularly in the context of experimental design. Understanding this concept is important when evaluating how different research studies are conducted. We'll break it down into key concepts, important details, and examples to make everything clear. What is an independent variable? Independent variable. The independent variable is the factor that researchers manipulate or change to observe its effects on another variable, called the dependent variable. The DV is what is measured in the experiment to see if it is affected by the 4. Example: in a study examining the effect of study habits on test scores. Independent variable, the type of study method. Dependent variable, the test scores achieved by the students. What does no direct manipulation of the 4 mean? When we say there is no direct manipulation of the 4, it means that the researcher is not actively changing or controlling the independent variable to see its effects. This often happens in observational or correlational research instead of experimental research. Key concepts. 1. Descriptive studies. In descriptive research, the researcher observes and describes behaviors or characteristics without changing any variables. Example: a researcher might survey students about their study habits and then correlate those habits with their test scores, but they do not manipulate the study habits themselves. 2. Observational studies. In observational studies, researchers can collect data on how subjects behave in natural settings without intervening or altering their environment. Example: researchers might observe a group of students in a school to record how they study, but do not tell them how to study or change their study environment. 3. Correlational research. In correlational research, researchers look at the relationship between 2 variables without manipulating either one. Example: if researchers find a correlation between hours spent studying and test scores, they can report this relationship but do not manipulate the amount of time students spend studying. Important details. 1. Limitations of no direct manipulation. Causation versus correlation. Because the researcher is not manipulating the 4, it can be difficult to establish a cause and effect relationship. Just because 2 variables are related does not mean one causes the other. Example: if a researcher finds that students who study more tend to get higher scores, they cannot conclude that more studying directly results in better scores without experimenting with study methods. 2. Ethical considerations. Sometimes, it is not ethical to manipulate variables directly. For instance, in psychological research on stress, deliberately inducing stress in participants could be harmful or unethical. In such cases, researchers may choose to study existing differences in stress levels without manipulation. Example: researching natural stress responses in high-stress professions without inducing any stress in participants is an ethical approach. 3. Qualitative research. In qualitative research, researchers gathered detailed descriptions and understandings of behaviors without manipulating the variables involved. This approach provides rich insights into experiences and perspectives, but lacks the control needed for testing causal relationships. Example: conducting interviews with students about their experiences with different study techniques allows researchers to gather insights without manipulating those techniques. Example of no direct manipulation of the four. Let's say researchers want to study how the environment affects concentration levels among students. 1. Research goal: to explore the effects of a quiet environment versus a noisy environment on students' ability to concentrate. 2. Method: instead of creating a quiet room and a noisy room, researchers might observe two different groups of students. Group A studies in a quiet library. Group B studies in a crowded cafeteria. 3. Data collection: researchers then measure how well each group performs on a concentration test after studying in those environments. 4. Results: the researchers can compare the test scores without directly manipulating the study environments. They can observe how the existing environments impact concentration, but cannot definitively conclude that one environment causes better concentration than the other. Conclusion: the phrase, "no direct manipulation of the four," indicates that researchers are observing relationships between variables without changing any factors involved. This approach is common in observational and correlational research, but limits the ability to establish cause and effect relationships. By understanding this concept and its implications, you'll be better equipped to evaluate various research designs as you prepare for your CPC exam. Correlation coefficient. Sure, let's discuss the correlation coefficient, an important statistical measure used to express the degree of relationship between two variables. We'll break down its key concepts, important details, and examples to make it easy to understand. What is the correlation coefficient? The correlation coefficient, often represented as R, is a numerical value that ranges from -1 to +1. It measures the strength and direction of the linear relationship between two variables. The closer the value is to +1 or -1, the stronger the correlation. Here's how to interpret the values. R equals +1, perfect positive correlation. When one variable increases, the other variable also increases perfectly. R equals -1, perfect negative correlation. When one variable increases, the other variable decreases perfectly. É igual a zero, no correlación. There is no predictable relationship between the two variables. Key concepts. 1. Positive correlation. A positive correlation occurs when both variables increase together. For example, if we have a correlation coefficient of +0.8, it suggests a strong positive relationship. Example: in a study, researchers find a correlation coefficient of +0.9 between the number of hours studied and test scores. This indicates that as the study time increases, test scores tend to increase as well. 2. Negative correlation. A negative correlation occurs when one variable increases while the other decreases. A correlation coefficient of -0.7 indicates a strong negative relationship. Example: if researchers find a correlation coefficient of -0.85 between hours spent on social media and grades, it suggests that as social media usage increases, grades tend to decrease. 3. No correlación. When the correlation coefficient is close to 0, it indicates little to no relationship between the variables. Example: a correlation of R equals 0.05 between shoe size and intelligence suggests that there is no meaningful relationship between these two variables. Important details. 1. Strength of the correlation. The absolute value of R indicates the strength of the relationship. Values close to +1 or -1 indicate a strong correlation, while values close to 0 indicate a weak correlation. Example: an R value of +0.95 indicates a very strong positive correlation, while an R value of -0.1 indicates a weak negative correlation. 2. Direction of the correlation. The sign of the correlation coefficient tells you the direction of the relationship. Positive: both variables move in the same direction. Negative: the variables move in opposite directions. 3. Linear relationship. The correlation coefficient measures only linear relationships, meaning it assesses how well the data fits a straight line. Curvilinear relationships may have significant associations that are not captured by the correlation coefficient. Example: if the relationship between hours studied and grades starts increasing quickly and then levels off, the correlation coefficient will not depict this complexity accurately. 4. Limitations. Causation. Correlation does not imply causation. Just because two variables are correlated does not mean one variable causes the other to change. Confounding variables. Other factors might influence the relationship between the two variables. For example, a strong correlation between ice cream sales and drowning incidents does not imply that eating ice cream causes drownings. Both could be due to warm weather. Example of calculating the correlation coefficient. Let's say we want to examine the relationship between hours studied and test scores among students. Calculate are using statistical software or formulas. You would input the data points to compute the correlation coefficient. In this example, you might find R equals plus 0.98, indicating a very strong positive correlation between hours studied and test scores. 2. Interpret R. You can conclude that there is a very strong relationship, such that generally, as students study more hours, their test scores increase significantly. Conclusion. The correlation coefficient is a valuable statistic that helps researchers understand the relationship between two variables. It provides insights into how changes in one variable may relate to changes in another. However, it's important to interpret this statistic wisely, remembering that correlation does not imply causation and considering the context of the data. Understanding the correlation coefficient will enhance your ability to analyze research findings and is crucial as you prepare for your CPC exam. Positive versus negative correlation. Sure, let's break down the concepts of positive correlation and negative correlation. These terms are used in statistics to describe the relationship between two variables. Understanding these concepts is important for interpreting data in research, especially in fields like psychology and social sciences. What is correlation? Correlation refers to a statistical relationship between two variables. It tells us whether and how strongly the two variables are related to each other. The relationship can be positive, negative, or even non-existent. Key concepts. 1. Positive correlation. A positive correlation means that as one variable increases, the other variable also increases. This indicates that the two variables go in the same direction. The correlation coefficient will be a positive number, ranging from 0 to +1. 2. Example of positive correlation. Hours studied and test scores. If students who spend more hours studying tend to get higher test scores, we have a positive correlation. For instance, if student A studies for 2 hours and scores 70, while student B studies for 4 hours and scores 90, we can see a pattern where more study time is associated with higher scores. Illustration. Positive correlation graph representing positive correlation. 4. Negative correlation. A negative correlation means that as one variable increases, the other variable decreases. This indicates that the two variables move in opposite directions. The correlation coefficient will be a negative number, ranging from 0 to -1. 5. Example of negative correlation. Stress levels and academic performance. If students with higher stress levels tend to have lower grades, we have a negative correlation. For example, if student A has low stress and scores 95, while student B has high stress and scores 65, we see a pattern where increased stress relates to lower performance. Illustration. Negative correlation graph representing negative correlation. Important details. 1. Strength of the correlation. The strength of the correlation can be measured using the correlation coefficient. Strong positive correlation, close to +1. Weak positive correlation, closer to 0 but still positive. Strong negative correlation, close to -1. Weak negative correlation, closer to 0 but still negative. 2. Interpreting correlation. It's essential to remember that correlation does not imply causation. Just because two variables are correlated does not mean that one variable causes the other to change. Example. While there might be a negative correlation between exercise and stress levels, This doesn't mean that exercising causes stress to decrease. Other factors might also play a role. Graphs, such as scatter plots, can help visualize correlations. In a scatter plot, points that trend upward indicate a positive correlation. Points that trend downward indicate a negative correlation. A random spread of points indicates a lack of correlation. Visual examples. 1. Positive correlation example. Imagine a scatter plot showing the relationship between hours of preparation for a cooking competition and the ranking achieved. You might see that most points trend upward, meaning as preparation hours increase, rankings improve. 2. Illustration, positive correlation. 3. Negative correlation example. Now, consider a scatter plot showing the relationship between the amount of time spent on mobile devices and academic scores. You might see that as the time on mobile devices goes up, the academic scores tend to go down, indicating a negative correlation. 4. Illustration, negative correlation. Conclusion. Understanding positive and negative correlations is essential for interpreting data in research. A positive correlation shows that two variables move in the same direction, while negative correlation shows that they move in opposite directions. Remember, correlation does not mean causation, and it is vital to consider other factors at play. This knowledge will be beneficial as you prepare for your CPC exam. Sure, let's explore biserial correlation and the phi coefficient, two statistical measures that help assess relationships between variables, especially when dealing with different types of data. We'll break down the key concepts, important details, and examples to make everything clear. What is biserial correlation? Biserial correlation is a measure used to assess the strength and direction of the relationship between one continuous variable and one dichotomous variable. A dichotomous variable is one that has only two categories. Key concepts of biserial correlation. 1. Continuous variable. This is a variable that can take any value within a given range. For example, height, temperature, or test scores. 2. Dichotomous variable. A variable that has only two categories. Examples include gender, yes-no decisions, or success-failure. 3. Purpose. Biserial correlation helps researchers understand how a continuous variable relates to a dichotomous variable. For instance, you might want to see if there's a relationship between hours studied and passing a course. Example of biserial correlation. Let's say researchers want to study the relationship between students' test scores and whether they pass or fail. Data, test scores, 60, 75, 82, 95, etc. pass or fail. Analyzing this data using biserial correlation could show whether higher test scores are associated with a higher likelihood of passing the course. What is the phi coefficient? The phi coefficient is another statistical measure used to assess the strength of a relationship between two binary variables. It is useful when both variables can be classified into two categories. Key concepts of the phi coefficient. 1. Dichotomous variables. Like biserial correlation, the phi coefficient looks at two variables that have two categories each. For example, whether students attend a workshop and whether they pass a test. 2. Purpose. The phi coefficient helps quantify relationships between two binary variables, providing a value between -1 and +1. A value close to +1 indicates a strong positive relationship, while a value close to -1 indicates a strong negative relationship. 3. Calculation. The phi coefficient can be calculated using a 2-by-2 contingency table, where the data is summarized in a matrix showing the frequency of occurrences for each combination of the two dichotomous variables. Example of the phi coefficient. Imagine researchers want to find out whether attendance at a study group is related to passing a final exam. Data summary. Passed, failed, attended 25, not attended 10, 15. In this example, 20 students attended the study group and passed. 5 students attended the study group and failed. 10 students did not attend and passed. 15 students did not attend and failed. Using the information from this table, researchers can calculate the phi coefficient to see how attendance is related to passing the exam. Important details. 1. Interpreting biserial correlation. A biserial correlation of plus 0.6 would indicate a strong positive relationship, meaning as the score increases, the chance of passing also increases. A biserial correlation of minus 0.4 would indicate a moderate negative relationship, suggesting that as scores increase, passing becomes less likely. 2. Interpreting the phi coefficient. A phi coefficient value of plus 0.7 would indicate a strong positive relationship between attending the study group and passing the exam, suggesting that students who attend are likely to pass. A phi coefficient value of minus 0.5 would indicate a moderate negative relationship, which could suggest that not attending tends to be associated with failing. Trois usages. Both biserial correlation and the phi coefficient are widely used in the social sciences and educational research to understand relationships between different types of data. Conclusion. Biserial correlation measures the relationship between a continuous variable and a dichotomous variable, while the phi coefficient measures the relationship between two dichotomous variables. Both help researchers understand how different variables relate to each other and can provide useful insights in fields like psychology, education, and social sciences. Understanding these concepts will be beneficial as you prepare for your CPC exam. Causal comparative research. Sure, let's explore causal comparative research, a type of research design that helps us understand the relationships between variables and how one variable can influence or relate to another. We'll break it down into key concepts, important details, and examples to make everything clear. What is causal comparative research? Causal comparative research is a type of research that seeks to identify and understand cause and effect relationships between variables. However, unlike experimental research, researchers do not manipulate the independent variable. Instead, they compare groups that naturally differ on that variable to see if there are differences in an outcome. Key concepts. 1. Independent and dependent variables. Independent variable. This is the variable that is presumed to have an effect on the other variable. In causal comparative research, the 4 is not manipulated. It simply exists in the natural environment. Dependent variable. This is the outcome that researchers measure to see if it is affected by the independent variable. Example. If researchers are studying the impact of different teaching methods on student performance, they may compare test scores across different classrooms, where one uses traditional methods and another uses project-based learning. 2. Groups. In causal comparative research, participants are divided into groups based on different levels of the independent variable. Example. A study comparing students who study in a quiet environment versus those who study in a noisy environment. One group is compared to the other to see how the environment impacts their test scores. 3. Natural comparison. Unlike experimental research, where the researcher controls the conditions, causal comparative research looks at groups that already differ on the independent variable as it naturally occurs. This design is often used when it is not ethical or practical to manipulate the independent variable. Important details. 1. Purpose. The main goal of causal comparative research is to identify potential causes and effects, providing insights into how variables relate, which can help guide future experimental research. It is particularly useful in situations where experiments are not feasible due to ethical concerns or practical limitations. 2. Limitations. Causation versus correlation. Just because two variables appear related does not mean one causes the other. Other factors may influence the results. No random assignment. Because the study relies on existing groups, there is no random assignment to conditions. This can lead to biases in results. Confounding variables. Researchers must be careful to consider other variables that might affect the results. For example, differences in student motivation or prior knowledge could impact test scores independently of the teaching method. 3. Data collection. Data can be collected through surveys, tests, existing records, or observations to compare the outcomes between the groups. Researchers analyze differences between groups statistically to draw conclusions. Example of causal comparative research. Let's say researchers want to explore the effects of physical activity on academic performance among high school students. 1. Research goal. To investigate whether students who participate in sports have higher GPAs than those who do not participate. 2. Group definition. Group A. Students who participate in school sports. Group B, students who do not participate in any sports. 3. Data collection. Researchers gather data on the GPAs of both groups at the end of the school year. 4. Analysis. They analyze the GPAs to see if there is a significant difference between the two groups. If Group A generally has higher GPAs than Group B, researchers might conclude that participation in sports could be associated with better academic performance. 5. Interpretation. However, researchers must consider other factors that might influence GPA, such as study habits, socioeconomic status, or overall engagement in school, to avoid drawing incorrect conclusions. Conclusion. Causal comparative research is a valuable design for exploring relationships between variables where direct experimentation is not possible. By comparing groups with naturally occurring differences in the independent variable, researchers can gain insights into potential causes of changes in the dependent variable. Understanding this research method will be beneficial as you prepare for your CPC exam and evaluate the quality of research in various fields. Descriptive research. Sure, let's explore descriptive research, specifically focusing on surveys. This type of research is widely used, especially in social sciences, to gather information about people's attitudes, behaviors, or characteristics. We'll break down the key concepts, important details, and examples to make everything clear. What is descriptive research? Descriptive research is a method used to describe and summarize characteristics of a population or phenomenon. This type of research focuses on providing a detailed account of the what, where, and when of a situation, rather than explaining the reasons behind these characteristics. Surveys are one of the most common methods used in descriptive research. Key concepts. 1. Purpose. The main purpose of descriptive research is to provide an accurate portrayal of a subject or group. It aims to gather data that can help summarize and better understand various aspects of a population. Example, a survey might seek to understand the opinions of students about their school cafeteria food. 2. Surveys. A survey is a tool used to collect data from a group of people by asking them questions. Surveys can be conducted using questionnaires, interviews, or online forms. They can include both closed-ended questions and open-ended questions. 3. Types of surveys. Cross-sectional surveys. These surveys collect data at a specific point in time. They provide a snapshot of a population's attitudes or behaviors at that moment. Longitudinal surveys. These surveys collect data over a longer period, allowing researchers to observe changes and trends over time. Important details. 1. Benefits of descriptive research through surveys. Wide reach. Surveys can reach a large number of people, allowing researchers to gather data from diverse populations. Cost-effective. Surveys, especially online ones, can be relatively inexpensive to administer. Flexibility. Surveys can cover a wide range of topics and can be customized to suit specific research needs. 2. Limitations of descriptive research through surveys. Response bias. People may not always answer truthfully or might interpret questions differently. For example, someone might exaggerate how much they exercise. Sampling bias. If the sample is not representative of the overall population, the results may not accurately reflect the views of everyone. Limited depth. Surveys can gather a lot of data, but they may not provide deep insights into why people feel or behave a certain way. 3. Data analysis. After collecting survey responses, researchers analyze the data using statistical methods. This can involve calculating averages, percentages, or identifying trends and patterns in the responses. Example, if a survey shows that 70% of students are dissatisfied with cafeteria food, researchers could further analyze what specific aspects students dislike. Example of descriptive research using surveys. Imagine a school wants to understand the student body's opinions about the effectiveness of mental health resources provided at the school. 1. Research goal, to find out how students perceive the mental health services available to them. 2. Survey design. The school creates a questionnaire that includes both closed-ended questions and open-ended questions. 3. Data collection. The questionnaire is distributed to all students, either online or in paper form, to collect responses. 4. Data analysis. After collecting responses, school administrators compute the average ratings and identify common themes from the open-ended answers. For example, if 60% of students rated the services as a 3 or below, and many mention long wait times, the school can clearly see areas that need improvement. 5. Reporting. The findings are summarized and shared with school staff and administrators to help guide decisions about improving mental health services. Conclusion. Descriptive research using surveys is a powerful tool for gathering data about opinions, attitudes, and behaviors in a population. By understanding the characteristics of a group, researchers can make informed decisions and identify areas for improvement. This knowledge will be beneficial as you prepare for your CPC exam and evaluate research methods in various fields. Response rate. Sure, let's discuss response rate, an important concept in research, particularly when conducting surveys. Understanding response rates is crucial for evaluating the reliability and validity of survey results. We'll break it down into key concepts, important details, and examples to clarify everything. What is response rate? Response rate is the percentage of people who respond to a survey or questionnaire out of those who are invited to participate. It is a measure of how many individuals completed the survey compared to the total number of people who were given the opportunity to participate. Key concepts. 1. Calculation of response rate. The response rate is calculated using the following formula. 2. Response rate equals 100 text equals left times 100 response rate equals 100. Example. If a school sends out 200 surveys to students and 150 students complete and return the surveys, the response rate would be 3. Response rate equals 100 equals 75% text equals left times 100 is equal to 75% response rate equals 100 equals 75%. 4. Importance of response rate. A higher response rate generally indicates a more reliable and representative sample of the population. It helps researchers understand how engaged the respondents are and the validity of the data collected. Example. If a survey has a response rate of 90%, researchers can feel more confident that their findings reflect the opinions of the entire population. Conversely, a 20% response rate raises concerns about whether the results are representative. 5. Types of respondents. It's important to consider who is responding. If most of the responses come from a specific group, it might skew the results. This is called non-response bias. 6. Factors influencing response rate. Several factors can affect response rates, including survey length. Shorter surveys often yield higher response rates. Timing. Sending surveys at a convenient time helps increase responses. Incentives. Offering incentives can motivate people to complete the survey. Follow-ups. Sending reminders can increase responses, especially for longer surveys. Important details. 1. Interpreting response rates. A high response rate is desired, but it's also crucial to evaluate the quality of responses. For example, a 100% response rate with poor quality responses is less useful than a 50% response rate with thoughtful, detailed answers. Some social science studies aim for a response rate of 60% or higher to ensure credibility. 2. Implications of low response rates. If response rates are low, there may be concerns about the reliability of the findings. It could indicate that the sample does not adequately represent the broader population. Example, if only 10% of employees respond to a workplace satisfaction survey, the results may reflect only the views of those who felt strongly enough to respond, leaving out the opinions of the majority who didn't reply. 3. Improving response rates. Researchers can take steps to boost response rates, such as making surveys easy to complete, sending surveys via preferred methods of communication, providing clear information about the purpose of the survey and how responses will be used. Example of response rate. Scenario. A university wants to gather feedback from its students about online learning experiences. 1. Survey distribution. The university sends out a survey to 500 students. 2. Responses received. Out of those students, 325 complete the survey. 3. Calculating response rate. Using the formula. 4. Response rate equals 100 equals 65% text equals left times 100 is equal to 65% response rate equals 100 equals 65%. 5. Interpreting the response rate. A 65% response rate suggests a fairly good level of engagement among students, providing reasonably reliable feedback about online learning experiences. Conclusion. Response rate is a critical measure in survey research, reflecting how many people participated in providing their opinions or data. Understanding response rates helps researchers assess the validity of their findings and indicates how well their sample represents the larger population. Aiming for a high response rate can lead to more credible and actionable insights, which is important for effective decision-making. This knowledge will help you evaluate research studies as you prepare for your CPC exam. Sure, let's explore what a cohort study is. This is an important research design often used in fields like epidemiology, psychology, and social sciences. We'll break down key concepts, important details, and examples to clarify everything. What is a cohort study? A cohort study is a type of research design used to observe the outcomes of a specific group of people over time. In a cohort study, researchers follow a group of individuals who share a common characteristic or experience during a certain time period. This design helps researchers look for relationships between exposures and outcomes. Key concepts. 1. Cohort. A cohort is a group of individuals who share a similar characteristic. This could be based on a specific time period, location, or shared experience. Example. A cohort could consist of all the students who graduated from a high school in a certain year. 2. Types of cohort studies. Prospective cohort study. Researchers identify participants and follow them forward in time to see how different factors affect outcomes. For instance, tracking a group of smokers and non-smokers over several years to see who develops lung cancer. Retrospective cohort study. Researchers look backward in time at existing records to find associations. For example, examining medical records of individuals from 5 years ago to see if high cholesterol levels are linked to heart disease. 3. Data collection. In cohort studies, data can be collected through surveys, interviews, health records, or direct observation. Researchers regularly check in with participants to assess their health, behaviors, and other relevant information. Important details. 1. Aim of cohort studies. The primary goal of cohort studies is to identify risk factors and outcomes over time. Researchers can see if exposure to certain conditions, like a specific diet, environment, or medication, leads to specific outcomes. 2. Longitudinal design. Cohort studies are considered longitudinal because they observe the same group of people repeatedly over time. This allows researchers to track changes and developments. 3. Advantages of cohort studies. Strong evidence. They provide strong evidence for establishing relationships between exposure and outcome, as researchers can see how changes in exposure affect outcomes over time. Temporal relationships. Researchers can determine if exposure occurred before the outcome, helping to establish cause and effect relationships. 4. Limitations of cohort studies. Time-consuming. They require a long period for data collection and follow-up, which can make them expensive and time-intensive. Loss to follow-up. Participants may move away or drop out of the study, complicating the analysis and potentially biasing results. Confounding variables. Other factors may influence outcomes, necessitating careful control in the study design and analysis. Example of a cohort study. Let's consider a cohort study designed to investigate the long-term effects of physical activity on mental health. 1. Research goal. To determine whether regular physical exercise is associated with lower anxiety levels over time. 2. Cohort definition. Researchers recruit a cohort of young adults aged 18 to 25 years, categorizing them into 2 groups. Active group, those who engage in regular physical exercise. Inactive group, those who do not engage in regular physical exercise. 3. Data collection. Researchers collect baseline data on participants' anxiety levels and physical activity levels using surveys. They follow up with both groups annually for 5 years, assessing their mental health and physical activity. 4. Analysis. By comparing anxiety levels between the active and inactive groups over time, researchers can assess whether regular physical activity is associated with lower anxiety levels. 5. Conclusion. If the study finds that the active group consistently has lower anxiety levels than the inactive group, researchers could conclude that engaging in regular physical activity may be associated with better mental health outcomes in young adults. Conclusion. A cohort study is a valuable research method that allows researchers to observe the long-term impacts of certain exposures on outcome variables. By following a specific group of individuals over time, researchers can gather valuable insights into health behaviors, risks, and outcomes. Understanding cohort studies is essential as you prepare for your CPC exam and evaluate various research designs in the social sciences and health fields. Variables. Independent variable, manipulated by the researcher. Sure, let's explore the concept of the independent variable, which is a crucial part of research and experimentation. Understanding the independent variable is essential for analyzing how different factors affect outcomes in various studies. We'll break down the key concepts, important details, and examples to clarify everything. What is the independent variable? The independent variable is the variable that researchers manipulate or change in an experiment to observe how it affects another variable, known as the dependent variable. The independent variable is often considered the cause, while the dependent variable is the effect or outcome. Key concepts. 1. Manipulation. In experiments, researchers actively change or control the independent variable to see how it influences the dependent variable. Example. If researchers are studying the effect of different amounts of sunlight on plant growth, the amount of sunlight is the independent variable. Researchers might manipulate it by giving some plants full sunlight and others partial sunlight. 2. Dependent variable. The dependent variable is what the researchers measure in the experiment to see if it changes due to the manipulation of the independent variable. Example. Continuing with the plant study, the dependent variable could be the growth of the plants. Researchers will observe how changes in sunlight affect plant growth. 3. Experimental design. Having a clearly defined independent variable is essential for experimental design. It helps researchers form hypotheses and determine how to interpret their findings. Good experiments will only change one independent variable at a time to maintain control over the experiment. Important details. 1. Characteristics of the independent variable. The independent variable should be clearly defined and measurable. This allows researchers to manipulate it effectively and make accurate observations. Example. If studying the impact of study methods on exam scores, the independent variable might be the method of study. Researchers can easily manipulate this by assigning different study methods to different groups of students. 2. Types of independent variables. Categorical. Sometimes, the independent variable involves categories rather than numerical values. For example, researchers might compare different teaching styles as the independent variable. Continuous. Other times, the independent variable is numerical and can take on a range of values. For example, the amount of exercise in hours could be a continuous independent variable in a study examining its effect on weight loss. 3. Control variables. In addition to the independent variable, researchers must control other factors that could influence the dependent variable. These are called control variables or constants. By keeping these factors consistent, researchers can be more confident that any changes in the dependent variable are due to the manipulation of the independent variable. Example. In the plant growth experiment, factors like soil type, water amount, and temperature should be kept constant to ensure that any growth differences are solely due to the amount of sunlight provided. Example of an independent variable in an experiment. Let's say researchers want to study how noise affects students' concentration levels during study sessions. 1. Research goal: to investigate how different noise levels impact students' ability to concentrate. 2. Independent variable: the level of noise during study sessions. Researchers decide to manipulate this by creating 3 different conditions. Group A: study in silence. Group B: study with low-level background noise. Group C: study with high-level noise. 3. Dependent variable: the concentration level of students. Researchers could measure this based on how many math problems they can solve correctly in a set amount of time or their performance on a concentration task. 4. Data collection and analysis. After conducting the study, researchers analyzed the results to see if students in the silent group performed better compared to those in the low noise and high noise groups. 5. Conclusion. The researchers can conclude how different levels of noise affect students' concentration, providing insights into the best conditions for studying effectively. Conclusion. The independent variable is a fundamental concept in research, representing the factor that researchers manipulate to observe changes in the dependent variable. Understanding the independent variable helps clarify cause and effect relationships, which is essential in scientific studies. By clearly defining and controlling the independent variable, researchers can make more accurate conclusions about their experiments. This knowledge will be beneficial as you prepare for your CPC exam and evaluate various research methodologies. Dependent variable, outcome, or measure data. Sure, let's explore the concept of the dependent variable, which is a key element in research and experiments. Understanding the dependent variable is crucial for analyzing how different factors influence outcomes. We'll break down the key concepts, important details, and examples to help clarify everything. What is the dependent variable? The dependent variable is the variable that researchers measure in an experiment to see how it is affected by changes in the independent variable. In other words, the dependent variable is what you observe or record as the outcome of your study. Key concepts. 1. The role of the DV. The dependent variable is the effect or outcome that results from manipulating the independent variable. It directly depends on the independent variable. Example: if researchers are studying how different amounts of sunlight affect plant growth, the height of the plants is the dependent variable. They measure how tall the plants grow in response to varying sunlight levels. 2. Measurement. The dependent variable must be measurable so that researchers can collect data and draw conclusions based on their findings. This can involve numbers, categories, or other quantifiable aspects. Example: in a study examining the impact of study methods on exam scores, the dependent variable would be the student scores on the exam, a numerical outcome that researchers can easily measure. 3. Outcome of the experiment. The dependent variable represents what the researchers are ultimately interested in understanding or examining. The hypothesis in an experiment often predicts how changes in the independent variable will affect the dependent variable. Example: in an experiment to determine whether exercise improves mood, the researchers would measure mood changes after different exercise routines. Important details. 1. Characteristics of the DV. The dependent variable should be clearly defined and relevant to the research question being asked. This allows for effective data collection and analysis. Example: if studying how diet affects weight loss, the dependent variable should be specifically defined as weight loss in pounds, making it easy to quantify and analyze results. 2. Graphical representation. In graphs, the dependent variable is typically plotted on the y-axis, while the independent variable is plotted on the x-axis. This visual representation helps illustrate the relationship between the two variables. Example: if you were to graph the relationship between hours studied and exam scores, the x-axis would show the hours studied, and the y-axis would show the test scores achieved. 3. Variation across levels. The dependent variable can vary across different levels of the independent variable. Observing these variations allows researchers to identify trends or patterns. Example: in a study on the effectiveness of different teaching methods on student performance, student test scores might increase with hands-on activities, showing different outcomes based on the method used. Example of a dependent variable in an experiment. Let's say researchers want to understand how sleep affects academic performance in high school students. 1. Research goal: to investigate whether more hours of sleep lead to better academic performance. 2. Independent variable: the number of hours of sleep students get each night. 3. Dependent variable: student academic performance, measured by their grades or test scores. 4. Data collection. Researchers might survey students to record their average hours of sleep each night, and then collect their GPAs or test scores at the end of the semester. 5. Analysis. After collecting data, researchers analyze whether there's a relationship between hours of sleep and academic performance. If they find that students who sleep more tend to have higher GPAs, they can conclude that sleep may positively affect academic success. Conclusion: the dependent variable is an essential concept in research, representing the outcome that researchers measure to see how it is influenced by the independent variable. Understanding the dependent variable helps clarify the relationship between cause and effect, allowing researchers to analyze their findings effectively. This knowledge will be beneficial as you prepare for your CPC exam and evaluate various research methodologies. Organismic variables. Sure, let's explore the concept of organismic variables in research. Understanding these variables is important for recognizing factors that can influence outcomes, but are not directly controlled by researchers. We'll break down key concepts, important details, and examples to clarify everything. What are organismic variables? Organismic variables are characteristics or traits of the participants in a study that are inherent to them and cannot be manipulated or controlled by the researcher. These variables can influence how individuals respond in an experiment or study, but are not something that the researcher can change or manage. Key concepts. 1. Definition of organismic variables. These variables refer to the biological, psychological, or social characteristics of individuals that are part of study. They can include factors like age, gender, personality traits, health status, and more. Example: in a study looking at the effects of a new teaching method on student performance, students' prior knowledge or learning styles will be considered organismic variables. 2. Influence on outcomes. Organismic variables can significantly affect the results of a study. They may create variability in responses that researchers need to consider when interpreting their findings. Example: in researching the effects of exercise on stress reduction, individual differences such as baseline stress levels, physical fitness, or mental health status are organismic variables that could influence how effective the exercise is for each person. 3. Not under researcher control. Unlike independent variables, which researchers manipulate, organismic variables cannot be changed or controlled by the researcher. Instead, researchers must account for these variables in their design and analysis. Example: if a researcher conducts a survey on workplace satisfaction, factors like employees' years of experience, job roles, or personal circumstances are organismic variables that cannot be controlled but must be considered. Important details. 1. Types of organismic variables. Demographic variables. Characteristics such as age, gender, ethnicity, socioeconomic status, and education level. Example: in studying the impact of stress on academic performance, researchers might note that older students may respond differently than younger students. Psychological variables. Individual personality traits, mental health conditions, or cognitive styles. Example: in research on motivation and performance, personality traits like conscientiousness or extroversion could influence how motivated a person feels. Biological variables. Physical health, genetic predispositions, or neurological conditions. Example: in studies about medication effects, variations in individuals' metabolism rates due to genetic differences are organismic variables. 2. Importance in research. Acknowledging organismic variables is crucial for the accuracy and validity of research findings. Researchers need to consider how these variables may affect the outcomes and potentially bias the results. Example: when analyzing data from a study on a new drug, disregarding participants' pre-existing health conditions could lead to incorrect conclusions about the drug's effectiveness. 3. Statistical control. While organismic variables cannot be manipulated, researchers can use statistical techniques to account for their influence. This is done during the analysis phase of the study to help isolate the effects of the independent variable. Example: using statistical methods like regression analysis can help control for age or gender, allowing researchers to see more clearly how the independent variable impacts the dependent variable. Example of organismic variables in a study. Let's consider a study examining the effect of a new diet on weight loss. 1. Research goal: to investigate how a specific diet influences weight loss among participants. 2. Independent variable: the type of diet participants follow. 3. Dependent variable: the amount of weight lost over a certain period. 4. Organismic variables. Age. Younger participants may lose weight differently than older participants. Gender. Men and women may have different metabolic responses to the diet. Health conditions. Participants with pre-existing medical conditions may respond differently to the diet. 5. Data collection. Researchers measure weight loss over several weeks, while also noting these organismic variables. 6. Analysis. After gathering data, researchers analyze how weight loss varies across different age groups, genders, and health conditions, adjusting their conclusions based on these organismic variables. Conclusion. Organismic variables are important characteristics of study participants that researchers cannot manipulate or control. These variables can significantly influence research outcomes, and it's crucial for researchers to acknowledge and account for them in their studies. Understanding organismic variables will help you critically evaluate research findings as you prepare for your CPC exam and consider the factors that may affect study results. Confounding extraneous variables. Sure, let's break down the concepts of confounding variables and extraneous variables. Both of these terms are important in research design and data interpretation, and understanding them is key to conducting valid experiments. We'll go over the key concepts, important details, and provide examples to help clarify everything. What are confounding variables? Confounding variables are factors that can interfere with or distort the relationship between the independent variable and the dependent variable in a study. Essentially, confounding variables can create misleading conclusions about what is causing changes in the dependent variable. Key concepts. 1. Definition. A confounding variable is an outside influence that affects both the independent and dependent variables, making it seem like there is a direct relationship between them when there may not be.